Alright, so in this video, we are going to have a look at the trend, okay, for the isoelectronic species. So the isoelectronic species is a group of atoms and ions that have same electronic configuration. So basically, for atoms and ions that have same number of electrons, of course it will have same electronic configuration. So we call that atoms and ions as isoelectronic species. Okay, so for the first trend, okay, have a look at the combining period 2 and ion. So we have the period 2 and ion and also the period 3 cation. So untuk period 2 kita tengok ion yang bercharge negatif, kita combinekan dengan period 3 yang mempunyai ion yang bercharge positif. Okay, so both ions, okay, the anions and also the cations in these two periods have 10 electrons. So of course it is an isoelectronic species lah. Bilangan elektron dia sama, which is 10. Okay. So the anion from period 2 is N3 minus, O2 minus and also F minus. So these three ions comes from period 2. Okay, so these three anions come from period 2. Okay, so for sodium, Na plus, Mg2 plus and Al3 plus, these three cation comes from period 3. Okay, they are isoelectronic species with 10 electrons. Okay, so when the proton number increases, okay, so the proton number increases from N3 minus to Al3 plus. As you can see here, the proton number for nitrogen, okay, so the proton number for nitrogen is 7, okay, oxygen 8, fluorine 9, sodium 11, magnesium 12, aluminium 13. Okay, so this is the proton number for these ions. Okay, so kita boleh nampak lah from nitrogen to aluminium, from N3 minus to Al3 plus, the proton number increases. So when the proton number increases, so of course lah, the effective nuclear charge also increases. Okay, the charge that is felt by the outer electrons pun akan bertambah sebab dia punya proton number pun bertambah. And when that happen, okay, as usual, the attraction between the nucleus and the remaining electrons become stronger. Okay, attraction dia akan menjadi semakin kuat sebab tarikan kuat. Charge positif pada nucleus tu kuat. Okay, thus, okay, the ionic size decreases. That's why, okay, daripada period 2, okay, this one, here we have period 2 elements, period 2 ions, okay, dia akan semakin mengecil size dia sampailah period 3 ions. The second example for the isoelectronic species is across a period. So for example, if I take only period 3 elements. So the period 3 elements kita ada from Na plus, okay, we have Mg2 plus, Al3 plus, okay, Si4 plus, P3 minus, alright, P3 minus, and then we have what else? S2 minus and also Cl minus. So kita tengok ke semua ion ini adalah from period 3. Okay, so if that happen, okay, if the question asks you to explain the trend, okay, of the isoelectronic species across a period of the ions, okay, across a period. So kita kena bahagikan dia kepada 3 bahagian. Okay, the first part here saya bahagikan kepada positively charged ions. Okay, which is these 4. Okay, kita tengok, kita fokus kepada these 4 ions dulu. Okay, di mana Na plus, Mg2 plus, Al3 plus, Si4 plus, okay, kesemuanya adalah isoelectronic species with 10 electrons. Okay, dia ada 10 electrons. Okay, so like just now, we know that when proton number increases from Na plus to Si4 plus, of course, okay, when the proton number increases, okay, So of course the effective nuclear charge also increases. So okay, that makes the attraction between nucleus and remaining electrons become stronger. Okay, attraction dia akan semakin kuat. Thus, the ionic size decreases from Na plus to Al3 plus. Okay, oh ni tertinggal pula satu lagi. Bukan Al3 plus saja. So kita ada Si4 plus. Sampailah Si4 plus. Okay, and then the second part. Now we are going to jump from the positively charged cation, okay, the cation to the anion, okay, daripada Si4 plus kepada P3 minus. So since, okay, since the 3P minus, okay, since the P3 minus, okay, kita akan add electrons. The electrons are added to 3p orbitals. Okay, kita akan tambah 3 elektron dalam 3p orbitals. It will make the principal quantum number increases. So kita tahu n increases. Okay, so when that happen, when we add more electron, of course the repulsion between the electrons increases. Okay, thus when the repulsion increases, okay, the attraction between the nucleus and outer electrons will becomes weaker. Okay, it will make the ionic size increases sharply from Si4 plus to P3 minus. So daripada cation nak masuk kepada anion ini, awak akan nampak a sharp increase in the size of ion. And the last part, barulah kita discuss about the anion sahaja. So ini adalah anion, okay, negative charge ion. Okay, so dalam anion dia sama je sebenarnya macam dalam kita discuss cation tadi. Okay, di mana P3 minus, S2 minus, Cl minus semuanya adalah isoelectronic species with 18 electrons. Okay, so the proton number increases. Okay, proton number increases from P3 minus to Cl minus. So of course when that happens, the effective nuclear charge also increases. Okay, and the attraction between the nucleus and remaining electron become stronger. So that will make the ionic size decreases. So size daripada P3 minus until Cl minus akan berkurang. So if you look at this graph, okay, ini adalah graph ionic radius for the period 3 elements. Okay, saya ambil daripada buku. Okay, boleh carilah dalam buku rujukan. Okay, so daripada Na plus sampailah Si4 plus, awak akan nampak the size decreases. Sebab apa? Proton number bertambah, effective nuclear charge bertambah. So tarikan antara nucleus dan juga outer dan juga remaining electrons become stronger. That's why the size decreases. But then here, okay, the size increase sharply from Si4 plus to the P3 minus. This is because for P3 minus, we add 3 electrons into the 3p orbitals. So that makes the principal quantum number n bertambah. So bila n bertambah, okay, the repulsion between the electrons berkurang sebab tadi kita tambah elektron kan. Okay, and then the attraction between the nucleus and the remaining electrons become weaker. So that's why ada pertambahan size dekat sini. But then from P3 minus to the Cl minus, again dia ada kaitan dengan proton number. So proton number bertambah, effective nuclear charge bertambah. So the attraction between the nucleus and the remaining electrons pun getting stronger. That's why the size decreases.